Okay, wrapping up section 3, we're going to talk about the composition of functions. Okay, so the composition, I've kind of given you the definition from the book here. Basically what it is it's taking the output of one function and using it as the input for another. Okay, and you can see the symbolism, how we write these things. So up here you can see f of g of x can be written with that little small, kind of small o between them. And that can also be written as f of g of x with the g of x inside of the parentheses. Okay. When we talk about the domain of this composition, you have to use the x values. You can only use x values that are in the domain of g. Okay. And that all of the g of x values, which would be the range of g, has to be in the domain of f. So in order to find the domain of a composition, those two things have to be true. Okay. So let's look at some examples. So we've got two functions, f of x and g of x, and we want to find the composition f of g of x. So remember, that symbolism really means that I'm going to use g of x as the input for f. So I'm going to take this entire function g and replace the x's in function f with that whole expression. So what that looks like is 3, and I'm going to replace x with x squared minus 2x plus 6. And then I have the minus 4 still hanging out in the end. So once we make that substitution, it's all just simplifying. So we have 3x squared minus 6x plus 18 minus 4, which means f of g of x is 3x squared minus 6x plus 14. There's our function. Okay? And what is the domain of that function? Well, to do that, first I have to look at the domain of f, and I have to look at the domain of g. Well, the domain of f, being a linear function, is going to be negative infinity to infinity. G is a quadratic, so it too is going to be negative infinity to infinity. So the domain of the composition will also be negative infinity to infinity. There were no values left out of f and g, so I don't have to leave any values out of the composition. Okay. So B, g of f, going in the reverse. So now I'm using f of x and replacing all of the x's in g with f of x. So what's that going to look like? It's going to look like 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So now we have to start squaring all that out. 3x minus 4 squared, that's going to be 9x squared minus 24x plus 16 minus 6x plus 8 plus 6. So g of f of x would be 9x squared. Negative 24, negative 6 is negative 30x. 16 and 8 is 24 plus 6 would give me plus 30. And the domain again is going to be negative infinity to infinity. Okay, there are no values that are going to be left out of that. Okay. How about g of f of 1? Okay, g of f of 1 means basically take that function g of f and replace all of the x's with 1. So remember that g of f was 9x squared minus 30x plus 30. Okay? So g of f of 1 means 9 times 1 squared minus 30 times 1 plus 30. And we get 9. Okay? Okay, so now looking at these two problems, we got f of x is 2 divided by x minus 1, and g of x is 3 divided by x. So if we're looking at f of g of x, the first thing we need to figure out is what's the domain of g? Okay. Well, my domain over here is going to look like negative infinity to 0, and union that with 0 to infinity. I cannot allow 0 in the domain of g because then I would be dividing by 0. So when I look at f of g is going to be 2 divided by 3 divided by x minus 1. Right? Well, what values am I going to have to leave out? Well, I have to leave out 0 because that wasn't in the domain of g. But also, I'm going to have to leave out whatever makes this whole denominator equal to 0, and that would be a 3. So my domain is going to be negative infinity to 0, union that with 0 to 3, and union that with 3 to infinity. I can't use 0 in the composition because 0 is not part of the domain of g. It wouldn't give me an output to put in here. And now because of the new function, I also have to throw out the value of 3 because that would make this new denominator equal to 0 as well. And just kind of disregard this domain of f of g. That's what we kind of just looked at back there on the previous slide. Okay. So again, here are some rules for determining what has to be excluded. Okay. So we know that 3 has to be excluded. This is kind of the explanation here just in print of what I talked about in the previous problem there. Okay. When we put the g of x down here, the 3 divided by x, we cannot let that equal 1. So we have to disregard the value of 3 has to be excluded because it would make this entire denominator equal to 0, and we don't want that to be equal to 0. Okay? So we threw out the 0 because it wasn't part of the domain of g, and we threw out the 3 because it wouldn't fit into the domain of f of g. So those are the two values that have to be thrown out. Okay? So this is more of the explanation of part B that we did on the previous page there. Alright, decomposing functions. This is basically just working backwards. So we're trying to figure out two functions that when we take the composition would have given us this new function h. Okay? So what we're looking at here is we've got two things. We've got something raised to the 5th power. Okay? So if I look at that function, I've got something raised to the 5th. And what is it that's been raised to the 5th power? Well, what's been raised to the 5th power in h is this 3x squared minus 4x plus 1. Okay? So if we kind of work our way from the inside out, if I'm looking at f of g of x, then that means the g of x had to be plugged in to the f, which means that f of x would be the x to the 5th, and g of x would have been 3x squared minus 4x plus 1. Because this whole function here was taken and plugged in for that x, and that is what generated this new composition function h, where I would have had that entire trinomial raised to the 5th power. So decomposing is basically just kind of looking at it backwards. What two functions would I take the composition of to get the function I've got now? Okay? Alright, so for tomorrow, I want you to try these three problems. Okay, number 1, you've got a function f and a function g. Find f of g of x. Same thing in number 2, and I also want you to state its domain. Okay, so make sure you don't forget that part. And 3, here's a function h. Express that as a composition. So find me an f and a g that when I take the composition, I end up with that h. Okay? And then give me a summary, give me an explanation in your own words of how to find the composition of two functions. What does that mean? What would you have to do to find the composition? Okay? and we will see you tomorrow.